So welcome to this presentation. It's on syntactic processing. And a lot of this work, or all of this work, I should say, is based on this book, Syntactic Processes. Specifically, the book is An Introduction to Syntactic Processing Theory. The last chapter of it, Syntactic Processes. The motivation behind this work is that there's a theory in the psychology of linguistics that there needs to be a computational model that's efficient enough for humans to be able to process words as they receive them in conversation. This is also how humans see headlights, for example. So the theory is that humans, given any incomplete sentence, can at least fill in a word that's at least syntactically correct. To be able to do this, we need an efficient model to do this, and that's what we're going to be discussing. So if you look at the X-bar representation of this tree, everyone's familiar with this by now, you can see that there's some repetition that we want to avoid, specifically in the categories. You can see the tense.
Así no escucho.
No se escucha.
¿Me dice algo?
No hay un micrófono. Aquí no hay micrófono.
Ese es el micrófono.
Ese.
¿Te puedes sentar, corazón, y te hablas más sencillo?
Sí. Bueno, ustedes también.
So the tense is repeated 3 times, and so on. We want to eliminate this kind of repetition, right? So what are we going to do? We're going to replace category labels with arrows that are going to point to the head of a phrase. And if they're coming from, we'll get into more of the specifics later. Some key things to keep in mind: the original and move positions, move constituents are going to be visible to semantics, but only the move position is going to be visible to syntax. Okay. So this is the representation that we're talking about. You can see that the head has a category C, therefore it's a complementizing phrase. The arrow is pointing it. It's pointing at it, so that means it's the head. And we can also look at the maximal projection for the, which is DC the and MPT. Okay. Due to being the largest subtree, with the as its head. Okay. Well, we'll get into the details for how we construct this tree during the presentation.
What in the holy hell is this? I've never seen this in my life. What is this?
We'll get to it.
I'm not I am not a syntactician. I am not a syntactician. That's your field. I am learning this crazy stuff now.
We're gonna get
That's great.
So we want to pull extra items used in the tree to have a complete calculation. And we're going to identify the syntactic features that we're going to use in subsequent steps. So we only care about the ones that we're going to use later on. There are some that we're just going to totally forget about. And of course, Michael mentioned this a little bit in his presentation, so did Greco Bell before, but the efficiency from this model comes from the fact that for each grammar, the number of visible features in each derived structure is bounded by some k, and that would be determined by the particular linguist working on the tree or whatever this k is. Right? So we're going to look at Fred will eat the cake. That's going to be our example for today. And the way we keep track of the syntactic features that we're going to be using in subsequent steps is by surrounding them in boxes. That's going to be the notation. And so this is an example for the notation. Let's say we have cake, which is, it stays the same, right? Cake is not stays the same. Now, we might have an empty selector. That's what the E means. It's not pronounced. That selects some M. Okay? And you can see how the notation is going to translate that. So here's an example. Might look a little complicated, but like we said before, we're using arrows to indicate categories, right? So we're replacing categories with arrows. And the way the arrow is pointing indicates whether something is a specifier and the head of a phrase. So in this example, Fred is in the specifier position, and eats is the head of the phrase. So that makes this phrase a verb phrase. How did we get to this? Well, eats has some triggers. You can think of that. it needs two determinants. It's verb, so we're gonna merge it with a determinant. So each is gonna select K, and one of the triggers, if you remember from Michael's presentation, is gone. We don't care about this feature anymore, so the only feature that would remain is the other selector for another determinant, which will go to Fred.
No, I was about to sneeze.
Oh,
I thought you were like. No, good.
Anyhow, well, we'll do the merge again, and then we're done with the selection features, so they're gone. And we only have left the head of the phrase, which is B. Is that everybody clear there?
Yeah.
But the head of the phrase is eats.
Sorry?
The head of the phrase is eats. None of the other two are heads.
That's right.
So Fred doesn't have a head, is not a head. And cake is not a head.
The phrase is Fred eats cake.
Yes.
So it has, phrases can have only one head.
Wait, Fred eats cake is an entire sentence.
But that is the VP of the sentence, because that's your,
That's a VP.
that's your VP.
Yeah.
Yeah, but you have the complement of cake is the internal argument. Fred is external argument in the specified position.
But isn't then the internal argument a phrase in and of itself?
Yeah. So Fred and Kate are phrases of themselves.
Okay,
Oh, yeah, but.
that's what I'm asking.
But,
But
but this is the structure of a VP. Of course, everything has its internal structure.
yeah,
but
that's,
this is the VP.
okay.
That's why the head is it. This is the VP.
But because we're focused on the
And
verb.
the arrow always points towards the direction of the arc where you can find the head. Okay, so you see the arrow on the top. I mean,
So that
the
one-
Fred eats cake. It points towards the.
So you read this
to the
top
right.
down.
You can read it both ways, but it's how it
You'll
doesn't
get
really
to-
matter. It
Okay.
doesn't really matter because the arrow, the middle arrow points to the left, so that's where you have eat.
You could also.
Okay, so that tells you that's the head.
What's the efficiency in putting arrows instead of just verb phrase? So verb bar.
We're getting rid of redundancy.
Yeah, but it's also the fact that in a derivation, you should not have things that are not in your numeration. Okay, so the lexicon doesn't have things like VP or V's or things like that. Okay, so those are category labels that are just a mnemonic convenience for linguists, but it's not part of. It shouldn't be part of the computation. It shouldn't be part of the items that are getting into the computation. Those are just artificial labels. Yeah. So we're trying to minimize the kind of.
This is for a computer.
Well, you
What
can,
is that?
yeah, but actually it's a processing model.
Yeah.
We may do that. We don't probably think in terms of labels, VPs and MPs.
Of course not, yeah.
What we'll actually program, we'll get to that like closer to the end. So now we're getting to the derivation for your sentence for.
And I'm sorry, and that assumes that what we call noun phrases informally are actually determinant phrases.
Yeah, I know
But
that.
there is a category between determinant and noun, which is noun, like the number. Okay? So it's a functional category of the noun phrase structure. So that's, yeah.
Okay.
Well, actually, you need that in Spanish for the syntax of noun phrases. It's not that relevant in English, right?
There's not. It wasn't taught in English.
But that was taught.
Okay. All right.
This
All right.
feature equals n. It means it selects some n, and that n in this case is going to be fixed. So it selects state. And now the only syntactic feature that remains visible is now no. The derivation is never going to care again that state was an n selected by no, right?
Okay.
So we move on to step 2. And we assume that there was some that selects some noun, which was our only other visible feature, right? Because we want to get rid of these features so we can do the derivation. So we merge the determiner that previously built in NP, and the text is selected. And once again, we have only one syntactic feature visible. So now we're looking for something in our lexical array that is going to select this determiner. So we have this in our lexical array. We have eat, So each is gonna select the determinant, and now we still have one feature left that needs we need another determinant. We have two of the 8 lexical features that are invisible. And now we have a selection requirements. And how we're going to identify those selection requirements is going to be minus F or plus F. What this means in this case is we're going to use the extended projection principle. So this is the extended projection principle and completely, but we usually only refer to the second part when we're doing this therapy. And we're going to see that we're going to need to satisfy a licensing requirement for Fred to be able to take this place. So there's a licensing requirement created by merging Fred into the tree now. And we need to satisfy that with a plus EDP. That's how we're defining that. Some key things to keep in mind. We can only have one feature of license at a time. We can't have more than one. We could, but we would need to do some more complicated stuff. That's kind of out of scope. But the important part is that it is possible to have multiple features that need licensing. Is that clear? So now we're going to look for something in our lexical array to fulfill this extended projection principle requirement. So we do have that. We have will. So we're going to merge will, and now we have a plus EDP and a minus EDP in our tree. Something needs to happen here. This, if you can remember from Michael's presentation, this is, for example, the trigger. So that's going to trigger, and you're right. This is what I mentioned earlier. We have a strong constraint where we can't have 2 minus F features competing for the same plus F feature. But in this case, we only have 1 minus F feature and 1 plus F feature. So our minus F feature is going to go to the position of our plus F, right? So now we use move to bring the maximum projection of the minus F head, and we're going to move it into the specifier. Is that clear, right? We had a requirement to fulfill, so we fulfill it by moving Fred to Go.
Creo que para todo el mundo más o menos esto debe estar claro, pero entiendo que José no. José. Ok, por eso, bueno, just the gist, ¿ok? La idea es que, por ejemplo, lo que estaba presentando Diego hasta ahora mismo, cuando tenía Fred y Decay, es la estructura donde el verbo es el núcleo, o sea, el verbo es esencialmente el elemento que establece las relaciones entre las demás partes de la oración, ¿no? Así que por eso es que dice que es el núcleo y es el selector, ¿no? Es el que selecciona qué piezas son necesarias para poder formar una oración que sea sintácticamente aceptable o adecuada, ¿no? Así que todo esto ocurre acá. Each selecciona a Fred como agente, ¿no? Who's doing the eating, ¿no? Y selecciona the cake. Este nodo que está aquí representa the cake. Pero the cake a su vez se compone de the, que es determinante, y cake en singular. ¿Okay? Así que esta es la estructura interna de the cake. Entonces, lo que ocurre, ¿verdad? Cuando Diego habla de movimiento acá, que se refiere que, fíjate que si tú, el tiempo del verbo, ¿verdad? Es futuro, ¿verdad? Es distinto al verbo. Pero nosotros no decimos will Fred eat the cake. Eso sería como una pregunta, ¿verdad? Will Fred eat the cake? Yo digo, Fred will eat the cake, ¿verdad? Y eso se debe a que en esta posición, ¿verdad? Diego le llama correctamente el specifier of T, ¿verdad? A esta posición se mueve de la estructura, es un internal merge, o sea, como algo que ya está aquí. Voy a mover lo que sea de categoría D que esté más cercano a esta posición. O sea, tengo Fred y tengo OK, ¿no? Pero Fred está más cercano, así que este debe ser aquí.
Oh, that's
That's not good.
We don't do a track closest.
You don't do what?
We don't do a track closest.
Oh, okay.
That is why. So that's why we can't have more than one minus f feature competing for the same plus f.
Okay, you explain it. You explain it. Yeah,
There is-
you do it.
Okay, what's with the arrows?
Like two
words.
Yeah.
I don't get, well, this is the first time I see it, so I don't know. Why are you using arrows?
You're not the only one. That's right. Not the only one.
Huh?
You're not the only one.
Have you seen X bar before?
Probablemente no. Okay.
So the arrows are just notation. And
You're like reducing, the idea is to encapsulate multiple things.
yeah, because before
Like, why don't you use words?
the original representation that we were working with
Is that?
is this. This is X bar. So we have categories, and we want to reduce the redundancy of having multiple of these categories, right? You can see the tense, so T is repeated 3 times.
TP,
The
TR, T.
category.
And the thing is that when basically okay when we form structures out of words, yeah? But and this is supposed to represent the structure of a sentence. Okay? That's what these trees are. Okay? But if you see the trees contain a lot of the non-terminal nodes are just labels designed by by syntacticians, right? So it's not like in my head is something that is called a VP, okay, that I add with an DP or whatever. So those are just labels, taxonomic labels for different kind of categories and phrases. Right? So it should that be actually in the computation when it's probably not, because we form the sentence out of the lexical, out of Fred, out of Will, out of eat, the, okay, yeah. No, we don't compute with like VPs or V bars or things like that. These are just labels. These are just labels. So we want to reduce the representation to just the lexical items that enter into the computation. So, but the structures, syntactic structures have what's called a head. Okay? So, which means that there is an element of a structure that projects its properties, to part of the tree. Okay? So, for example, if you say, sleep, yeah, it's a verb, and it's a verb phrase. We say, he sleeps. Right? Sleep is a verb. We say, Fred eats cake. Yeah? You have again a verb phrase, eats cake, but it's not a verb. It's not just a verb. It's a verb and a complement, right? So, but anyway, in a sense, the verb sleeps and the verb eats cake. Yeah? The verb is the phrase eats cake. Okay? They're both of the same category verb. They're both verb phrases. So you can substitute one for the other in a sentence. They say Fred sleeps or Fred eats cake, okay? And you'll have sentences for both. They're different, of course, it means a different thing. But the fact that you can substitute one for the other, that means that they have the same syntactic category. Right? So you can replace things of the same category you can put them in the same position and still have a correct structure. Okay? A grammatical sentence. I mean. So okay, so the fact that they are both of the same category, eats cake or sleeps, it's because they are both phrases of the same type, the verbal phrases. What made that verbal phrases is that they both have as head a verb. So that's what the concept of head of a phrase. What is the category of whatever is in the tree that project its properties to that part of the tree, to the whole subtree. So for here, right, the whole thing, Fred and Kate, it's called a verb phrase because this phrase, the verb is the head is that determines that it needs this complement and this is the subject. Okay, but then we will have the verb phrase merges with the tense element will. Okay, to have some form of tense phrase. So it's not only the verb phrase, Fred eat the cake, but that is in the future. Okay, so that's so now T is the head of this part of this tree. V was the head of this tree, but T is the head. Okay? So and it's going to still be the head of this. Okay? But then when you add the what's called the complementizer, then that becomes the head. Okay? And this is so I know that it's a lot to swallow, okay? But just if it makes it a little bit less incomprehensible. Okay. Uh-huh.
I did mine for the arrow and see if I'm far off or not.
Diego will be the judge of that.
So, my understanding is that, so information is about the sentence lies inside the tree, and then the computer accesses it, sees like one node at a time. And then let's say there's information you want to access from the nucleus,
From the head.
the head of the of that node. Then the node itself knows where that lies in the structure, and if we're just, let's say, letter and each, we need to gather both tiles of the node and have a comparator, and then it's more computationally efficient just to know using the label where the head of that node lies. So it's less complicated.
Right.
Cuando vamos a hacer un poquito, está, ¿qué es lo que tiene que ver primero?
No un documento de esa, están los files, pero no, yo voy a, exacto. Claro.
Cuando
There is. Sí. Sí. Lo que tengo es que I hope so.
Yeah.
Yeah.
You know, like believe it or not, I was actually thinking of talking to Open about that at some point too, because like, we're doing a lot of this intro stuff, but every single semester we're doing more and more intro stuff. So it'd be nice to have like a place where all of the intro stuff is with directions on the suggested reading order.
Exactly.
So like, there's like some initial
That's
textbook, like these chapters have like a way of explaining such and such before seeing the first presentation of whatever. Right? So like,
There is a book that I don't use as a textbook, but it's I think it's probably the best one to learn by yourself. It's called Chomsky's Universal Grammar, and I think it's in the file. I'm going to because it goes like
I also think Carney is very good.
Carney.
Carney's is also really useful.
Yeah, that's true. That's true.
So, well, we can talk about it later.
Okay.
It was that accurate?
Yes, it does make it easier to just know what the head of the phrase is. So we can follow this and find the head of whatever, just in the same way that we could do this with Excel.
So what's up with the arrows?
The arrows point towards where the head of that phrase is. Okay? So that's the arrow. So for example, with this, I know that Fred cannot be the head. Okay, so I have to go down one branch. But then this tells me that the head goes in this direction, and this is the that means that this is the head.
It's for traversing.
Hmm? For
Traversing the tree.
yeah, for traversing
Yeah.
the tree, right?
But that
And
also has the arrow pointing towards it.
the arrow pointing towards.
If you go down to 8, so the first one that has the arrow pointed towards it is the head. How is that?
So wait, are we talking about the lowest one?
Yeah, I don't know which one is.
Yeah, that means that this is the head of this particular subtree.
Oh,
Okay. Okay, and this means that this is the head of this particular subtree. Is the head of this subtree. Okay, and this means that this is the head of this subtree. Okay, pretty much. So it's telling you where's the head. If you let's suppose that we're merging syntactic objects, where we're constructing the bottom up. Okay, so I mean, and the resulting node, okay, instead of having a label, it's just going to point towards what in that merge, which one of the two syntactic objects is the head. Okay, so every time you do merge, one of them is the head. One of them is the head of the resulting structure. Okay?
This could also be cut down. It would be like this, but this is just not big.
No problem.
The thing after the two colons, right, that's a category marker, right, of what pertains to that word, right? Why is cake labeled as determined?
Excellent question.
Why is what they were like?
Why go there?
The determiner is the.
Is that case that though? Is that,
What?
is that an N or is that? I
That's a
can't
D.
remember. No, but I mean
I don't remember.
in the
what
original example.
I don't remember what the book used. I know in the 2010 section, he uses N. I don't know if he changed. it
Yeah.
for the book.
Because otherwise it's telling me cake is a determiner within the determiner phrase.
No, but yeah, you are right. It's-
Yeah, you're right. Right. It should be. I guess it should be N.
Yeah, my bad. This is.
This is N. Yeah. It's N. It's N.
And then I have a second follow-up question on cake as well. Cake is the head of a noun phrase, so it should have an arrow.
No, but because the arrow is the result of the merge of the number category with cake.
So is
So we
cake,
are not, cake is the terminal node.
so can it be NP instead of N?
Yeah, so I
It
think.
is N and NP at the same time. Okay, minimalism, whatever category, whatever category does not have any selection or requirements, it's by definition a maximum phrase.
That's why we just
Okay.
select,
Phrase, yeah.
that's why we select NP. And we can just select whatever. we select.
And is Fred supposed to have a determiner marker as well?
Right? I believe. Fred did.
Oh, yeah.
It's a bit too much. The single colon is, double colon is, original. We derive from thing. That's what we like.
Okay.
And everything else that has single colon is derived.
Yeah, so all the cakes, some cakes are Ds and some cakes are Ns, so I should assume they're Ns.
Yeah, that was probably a typo. That's a typo. It's a typo. It's a cake.
There we go, okay, that's.
Okay, so yeah. We merge the consonant element into our verb phrase. And
Little quiz. What is the head of that tree? Look at the root. Look at the root and see where the head, where the arrow points.
You can look at the top node.
Look at the root.
one that covers everything pretty much. The top node one that. Look at which direction it points and go down that, right? If you keep going down until you end up at like a terminal node, that terminal node is in the head. So starting from the top, it tells us to go left. So we go down to the left and we see will. Because will is a terminal node, you stop there and say, yep,
That's it.
right?
Yeah, the arrow just points at the head. Okay, at the head has to be a terminal node. Okay? Es un grafo. Es un grafo. ¿No? Okay, sorry. Okay. Ve lo importante que es, después. ¿No? ¿Sí? Ah, exacto.
El head te queda el hijo de pero si estuvieras en el último nodo, en la cosita más abajo, queriendo ese root, no, el árbol es solamente el nombre y el root del head está a la izquierda.
If this were the tree, what's the root of that tree? What?
So you take the topmost node, the mother, and it says to go right.
Follow
So you go
the
down to
arrows.
right.
Follow the arrows on the root.
You go down to the right and there's another arrow, and it tells you to go to the left. Going down that left, you end up at eat.
That's
And because eat is not an arrow, you stop there.
That's your
stop
root.
that.
That's your head. So what kind of tree?
Oh, I don't know that.
Well, what eat? What category is eat? Then what type of verb? Well, so that means that this is a verb phrase. Yeah, the phrase, the name of the phrase is the name of the head. Okay, verbs, verb phrase are projections of verbs. Noun phrases are projections of nouns. Okay? I know. No, this is like the quick crash, traumatic course, mini course. No, but I'm trying to appeal to background knowledge and graph, from data structure. So just, okay. Yeah. And the assumption that that is. And the assumption that that eats is a verb. Yeah. Sorry for the interruption.
I'll get there. Sorry? I'll get there. Eventually.
We're gonna do it step by step.
Yeah.
So you'll see it.
So, if you remember, originally, what were we trying to say? We were trying to say, Fred will eat the cake. That's not what we have. This says, will Fred eat the cake, which is a question. So, we have like a built-in method for dealing with this, and that's minus f plus f. So, we're gonna move Fred to the positive EVP position, and that's gonna resolve both EVP elements. Okay. So, since Fred was competing for the position, Fred goes to the position, and we strike out the previous state of Fred.
When you say that Fred is competing for the position, what do you? What
No,
is
it's the only one going.
Okay.
Yeah. So right, we use the move operations, and now we finalize the tree with the complementizer.
Because yes.
Yeah, because that's the head of every sentence. Yeah.
Oh, because like, so-
No. I'm just trying to process all the squiggles.
Yeah.
It's very different.
Follow the arrows.
I know.
Pretty much what happened within the last thing that happened, we ended up with a tense phrase, right? And since in our lexical item array, we have this complementizer that's looking for a tense, as you can see where it says equal T, it's equal and then the thing it's looking for, right? We have a complete tense already ready, so that this complementizer can merge with it, and we end up with this structure where the complementizer merged with the completed tense phrase, right? And because the complementizer is the head of this movement, the arrow points towards the left.
Right.
And since the only visible feature here is the complementizer, we are done. And we have a complete grammatical of a sentence, which is what we were trying to form originally. Fred will eat the cake. And this is how we represent it using this arrow method.
Because correct, syntax, the structures that are well-formed structures cannot have any kind of feature or selection of feature that it has not been satisfied.
So this is still
If you have
minimalism.
that, you don't have a grammatical.
This is still minimalism. But this is a different notational take on minimalism.
This is a form, like a formalization.
Formalization of the workstation and all that stuff we were doing earlier with Mike.
Because mine was the worst situation, this is the better situation.
Really, I like yours.
Yeah, the thing about micro, we're assuming that we just have what we do, right? But we can combine this.
Right.
But you have, the thing is that it is it's pretty well assumed that that in syntactic derivations you cannot have things that are not within your lexical array. Okay, so when we form structure and we form sentences or phrases, we don't have things like called D or Ds or NPs or things like that. Okay, so we just have lexical items. Okay, so this is a way of representing exactly what the derivation of the structure without without adding elements that are not in the lexical array from which the structure is formed. Okay, so that's actually a syntactic principle. Okay?
By the way,
Otherwise, anything could,
the C and the bar, the complementizer, it's a lexical feature, and so is like everything else you see. So these are two lexical features, these are three, these are two, and so on. So some more notation. We're gonna define
Sadists. Oh my God.
yeah.
That's
So
pretty-
we've already seen this. We've already seen this.
Why are there sort of Damocles there? What's going on?
Right? Oh, these are just footnotes. The swords are footnotes, always. Okay. So
Always,
we
until
have-
they're a variable. That is.
No, they're not gonna.
Okay.
no.
Yeah.
Okay.
So we've already seen this, right? This is a selection feature for some feature F. So this could be anything, right? Whatever we're selecting. And T is the result in which that feature is no longer visible. We've already kind of seen this in the tree that we just did. Whenever we do an operation, when a feature is no longer visible, for example, the first one we did with cake and the MP event, this is what we did, right? Okay. So another thing, complements are merged on the right, and additional elements of the phrase are merged on the left in specified position. So like keep in mind. And this is what we use to define merge. So we have some first tree, so some initial tree with selection feature X, and some other tree too with that feature that we're selecting for. So we can merge these trees if okay. If we have exactly one node, that means the complement position isn't filled. What does that mean? We merge it in this way. Okay?
That means that T1 is going to be the head.
Exactly. T1 is going to be head, T2 is specified.
Is the complement.
That's right. Yeah. Exactly. So in any other case, meaning we have more than one, we have more than one node, then we want to merge it this other way, where T2 is going to be the head.
That is like the second merge where you have the specifier.
Exactly. Yeah.
That's after the second.
Exactly. It will be like a second merge.
Yeah, that's the first step.
Exactly.
No, it doesn't. do this.
But it needs a complement for getting some specific.
Oh, it's-
Right.
Yeah.
So that's all neat and dandy. When you have one argument,
No, that they have two there.
or two arguments, yeah, but the one that goes, so what happens with the ditransitive verb?
That could be. Then we need a little bit category, but this is for since we're trying to do just the trying to present just the mechanics of it.
Okay.
Of course, you can that is not a problem. This is not a syntactic problem.
Okay.
Yeah. When we get into more than one feature, we're gonna have to start doing other things. So a lot of this work is from Stegler, obviously. So he has a lot of ongoing work for like what we're gonna see later, like acronyms and whatnot.
And actually this is for presentation purposes. We are only using like V's, okay, just one V for the VP, okay? But for more complex, actually we will be using little big verb and little b, okay? So you'll have all the arguments you need with that configuration.
Does this make sense?
La cara lo dice todo.
This question already has an answer.
Where T1 is.
Exactly, because we could do an example perhaps of what would be an example of a T1 that has exactly one feature. It's within the tree, yeah? Okay, exactly. So it's just, yeah.
Actually,
That has two features, doesn't it?
Each state, for example, like this.
it's
Each
selecting
state.
features, but we're originally we're done.
How about a transitive verb? Fred sleeps, right? That would be two features. Well, one feature, sorry.
That is a case in which it's not equal to one, so that's probably the one that have the head pointing here. But that would be the case of if the thing is, you know what happens with intransitive verbs, okay? So sleeps, the verb phrase doesn't require any complement, right? So that's your verb phrase. So anyway, you still have an agent, okay? So depending on the representation, yeah, it will go like in classical X bar, it will be in the specifier of VP, okay? In minimalism, it will be the specifier of little b.
No.
Little b. Okay, so but it's the same mechanism because it's still heads merging.
But that's one feature, right?
Yeah.
Could have. Or it rains where it has no features.
No, but then you have the EPP feature, so something has to match.
Yeah, there's a higher feature.
Right.
So just to give you an example of what we just mentioned, merge, that's what we do here. So what is going on here?
That's his question for everything.
Is that rhetorical? Is that rhetorical?
I think if you gave him a spaghetti bowl, he would understand it about the same.
Yeah, we have a determinant, the, that is selecting for a node, right? Which is here. This was previously our only visible feature. So think of this as a trigger for this event. For this event, right? So this is going to select num, and now num is done. It happens because this merged.
Wait, why is there a D there now as a feature?
D is the, because
D,
that's,
D.
D is the determinant.
No, it was not there before. Right, if it's in the square.
That's number.
Oh yeah, we're talking about num here.
Right.
And then we select for, no, what we selected was this. We selected num.
Uh-huh,
B is still here because it hasn't been selected.
That's a second merge.
okay,
Yeah, that hasn't been.
even though it's further up already.
What?
No.
It's, none is down there already, right?
Yeah, but
Okay.
once you merge the selects K, so that becomes the phrase of the head of that.
What's the goal? What's the point of the box?
Just
Show
to
you
see
which
what-
syntactic features are still open. and still available
Yeah,
for
they're still visible for computation. So
Yeah.
whatever selects a D can see that structure has the D category.
Okay, so that one, okay, so that.
We
this
just
is-
want to, exactly,
this
the
is
box is that
second
what
to-
features are available and visible for
That's an
syntactic computation.
interpretable feature, right?
Yes,
An interpretable
yes.
feature, exactly.
We just say.
Yeah.
You're fine.
Mira, banderita a Cristóbal.
Un día me va a tocar a mí. Me va a tocar a mí. Y te voy a tratar igual. Te voy a tratar igual.
I'll be very harsh. I deserve it. I will deserve it.
Like, could it be like 1K?
It could be, but for purposes of this, derivation, we select like the word that we intend to use for our extension, right? So if we know we're gonna use this double we're gonna try to select them from whatever source we get from our supply, and then we're gonna check to see if it